fight first. What questions? Number, if we want to see you go over, have questions about. I'm seeing a lot of 1s, 2s, and 4s. I should probably have this in front of me so I can see what it is we're doing. 1, 2, and 4. And then 2 and 4 we can do in Desmos, as well as 5, so we'll also do those. So starting with 1 that cannot be done in Desmos. Translate the following. The quotient of, so we're dividing two things. 3 times a number squared, so that would be your first piece. 3 times, let's call it x squared. 5, 6 minus, x minus 6. So it looks something like that. Don't make that confusion. Try to keep things separate. Number 2 in Desmos. We are evaluating, so put negative 15 in. Negative 2, absolute value of negative 15.
So we're not doing anything like crazy, we're literally just solving.
Simplifying, but yes. Evaluating and simplifying, and that's it, yes. So if you were doing this by hand, when you put in the negative 15, added the 6, remember the absolute value bars make whatever's inside positive, so that would become a positive 9, and multiply to the negative 2. So negative 18 is that answer. Three, you could plot the points if you're doing it on Desmos. And then count the slope, but be careful while you're counting. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I definitely counted that. It's 6 and 12. Thank you. So that would be negative 1/2 because you're going down 1. So if I were to draw in a line, my slope would be negative 1/2. Questions on those? Four cannot be done in Desmos, so this is something you have to know. Range is lowest to highest. What is the lowest point on this? Correct, and the highest point? So I'm going to put this in both set notation, what we talked about at the beginning of the year, and interval notation, what we talked about with our inequalities. Would either be fine? Yes, either would be fine for me. You may not see interval notation on the SOL, which is fine.
So it doesn't matter?
Yes. You could do either for me, but on the SOL, only set
Only
notation.
that.
So either or. Questions on that one? And then 5, you have to graph y equals negative 3, which would be a horizontal line at negative 3. So make sure you have that graphed for number 5. Questions on those? So on Tuesday, you'll get 30, and then you'll turn in your chart by answer sheet and get a new one the following day. Okay. Let's go over the SOL standards. So I'm going to show you all the work and the answer, and then I'm going to show you in Desmos. And if you only did it in Desmos, that's fine. You don't need the work, but it would be good to have it just to refer back to. If you don't want to write the work and just write the answer, that's fine. Right. So for number 1, parts A, B, and C, you would find the slope of the given equation. So if you were doing the work, subtract 3x, divide everything by 2, your slope was negative 3 over 2. B, just divide everything by 3, so slope was 4 over 3. C, you really didn't need to do the work, but you could have simplified this because the slope was already given to you, step 2. Two and 3, you're given 2 sets of ordered pairs. And you could do y2 minus y1 over x2 minus x1 for both to find the slopes. So 2, the slope was 1/2. 3, the slope was 1. But you have to know that in order to get this ordered pair, x-intercept, it would be 4, 0, where y is the 0. Questions on those so far? Number 4 asks about the slope. So if you subtracted 8x, divided everything by 4, your slope was negative 2. If you look at that, there's a folder that says SOL standards. I think it's red. SOL standards. I think. That looks very good. Okay. Questions on any of these? Five was the same thing. Finding the slope between 2 points, so use your y2 minus y1. Slope was negative 4. And then for 6, it gave you that you had an x-intercept of 5 and a y-intercept of 3, so you had to know how to put those as ordered pairs, 5, 0, and 0, 3. And then you could do the slope formula for those and find that the slope was negative 3/5. Before we talk about SOL A.6a-b, I'm going to show you the ones on Desmos, and then we'll go back. So on Desmos, if you just type in the equation as is, count your slope, you'd be able to figure that out. Same thing with B and C, but again, C had it given to you, so you didn't really need to do that one. For 2, if you put in the 2 points, you could count your slope of 1/2. Same thing with 3, up 1, right 1. Four, it gave you a line, so you can count that slope, down negative 2. Count the slope from these two, but be careful. And then count the slope from these two, so down 3, 2. If you are not practicing these in Desmos, you should be, as it's going to be the only calculator you can use on the SOL. So make sure you are comfortable with putting this stuff into Desmos, knowing how to solve different things in Desmos.
Doesn't have to calculate for all of the questions.
Yeah. So you'll have the Desmos calculator for every single question. Right. 7, you had to plot 2 points on the line. How you did that was up to you. You could have solved this to find the slope and y-intercept and plotted the y-intercept and a slope point. Solved it for the y-intercept first. Tried to solve it for the x-intercept, but it would be a decimal, so it would be like somewhere in here. So either 2 points would have worked. Same thing with 8. You could find your y-intercept, solve it to get your slope. You could have kept doing your slope points and did different points. You could have did your x-intercept, which would have been some decimal. Any 2 points would have worked as long as it fell on the line. 9, you had to write an equation that passed through a specific point and had an x-intercept of 3. So if you use these two to find your slope, and then you could use either of the points to find your equation so that you could graph that equation. Or, once you find your slope, you could pick either of the 2 points and do that through the points. Pen was the same, but this time it gave you a y-intercept. So if you found your slope, then you didn't need to do the work to find the equation because the y-intercept was given. So you could graph your y-intercept, graph your slope. And then 11 is like 6, but more, because it gives you x-intercept and a y-intercept, which were the same as 6. The slope is the same. And since it gives you your y-intercept, you know your equations. You can put those together. Twelve is writing the equation that passes through a point that's also parallel. So you have to remember that parallel lines have the same slope. This is supposed to be off to the side. So when you go to rewrite this, you're using the slope of 2 and this point in your point slope formula. But when you write the equation, they end up being the same line, so they're not really parallel. And then once we go through all of these work-wise and answer-wise, then I'll show you those on Desmos. If I need to come back to it, I can do that. 13 is similar, but it's now perpendicular, so you have to remember that the slope is a negative reciprocal, so take it, flip it, make it negative. And it has to go through that point, so still using your point slope formula with your new slope, that would give you your equation of your line. 14, same thing, but it's now parallel again, so same slope, use your point slope formula. And you also had to get y by itself before you could figure out what your slope was. And then 15, same thing, but perpendicular, so negative reciprocal. Solve for y first. And then use the negative reciprocal, take it, flip it, make it positive, use your point slope. So what's nice is, if you don't remember the work for it, as long as you remember how to do it in Desmos, you'll be fine. And I'll show that here in a second. 7 on Desmos. And I think this one was graphing the line or plotting 2 points. That's what it was. So after you put that in, find 2 points. It can be your x and y intercept. You can make it. You could make that into a table and look for specific points. As long as you have 2 points, that's fine. Same thing for 8. You're looking for 2 points. So you could count your slope or use your x and y intercept. 10, you had to find the equation of the line. So if you put in the 2 points given, and you put in y equals mx plus b, add in sliders, you know what your y-intercept is. So we can change that to -3. Then we can play around with the slope until it goes through that point. So 0.8, so 4/5 is what we got. Only thing with this is you'll have to change it to a fraction if it's looking for a fraction. Same thing with 11. It gives you your y-intercept, 3. And if you counted the slope, you could put that in and make sure it works. So I know my slope is -3/5. And it should go through both of those. So that's a faster way to find your slope, find your equation without doing all that work. Twelve is the one where it was parallel to. So if you put in your point, put in the equation that it's parallel to. Because it's parallel, it has to have the same slope, so slope of 2. And then it has to go through this point. So you would just adjust this until it goes through that point. And it happens to be the same line. And you can do that for the perpendicular ones also. So put in your point, put in your equation. I thought I added this, but I did not. Change your slope to the negative reciprocal, so -1/4. And then adjust this until it goes through that point. It was 9, but then I moved away from it. It was supposed to be 9. So then -1/4 plus 9 would have been your answer, and you can keep doing that. (14) and 15 are the same, so I'm not going to show that again. When we talk about get closer to the SOL and we review some of our SOL Desmos hacks, that will be one that's used a lot, so just keep that in mind. Do you have any questions on any of those? Next Thursday, the following are due, and we're almost done with this packet. A6c, which is just one question, then A7a through D. So A7a, B, C, and D. So A6c and A7A through D. As a reminder, go back, rewatch the video so that you can get any of the work that you missed. Try them in Desmos on your own if you didn't. Everyone should have these notes in front of them. Today we're talking about the last way to factor. So as a reminder, we talked about GCF, where you take out what they have in common, difference of squares, where there are two perfect squares in a binomial, and you factor it out using those. The basic trinomials are A equals 1, where there are 3 terms, and the number here is 1, so you're looking for 2 numbers that multiply to the last, add to be the first, middle. This is kind of like that, but different, because it also talks about the grouping that we talked about last class. So it's like a mixture of a few different things. So I'm going to talk through the steps, and then we'll actually do some of these. So always look and see, does it have a GCF first? Because if you don't, you could end up with really big numbers instead of smaller ones that you can easily do. Even if the GCF is 1, at least you looked for it. Then, like the basic trinomials, this is when A does not equal 1 or it's greater than 1. You're going to take A and C and you're going to multiply those numbers together. Whatever numbers those are after they're multiplied together, you're going to find of those factors that multiply together, which of them add to be B. So that part's kind of the same, but a little different. Then we're going to take the 2 numbers and rewrite the 3 terms into 4 terms. So we're going to split the middle into those 2 new terms. And then we're going to do grouping to get our final answers. So it's a lot. So let's try some examples. You may need more space than what's on the box, so feel free to grab extra paper. So first, does this have a GCF? No, other than 1. So if it doesn't have 1, the GCF is always 1. I would say it would be good practice for this. That way, when you actually get a GCF, it's different than you have practice already. Then we're going to multiply 2 and 3. So 2 times 3 would give us 6. So we're looking for 2 numbers that multiply to be 6, that also add to be 5. 3 and 2 work. I'm color coding so it kind of helps you see if you want to also color code using this. So then we're going to take our 3 terms and split them into 4. The first and the last always stay the same. And instead of the 5x, you're going to use 3 and 2. And because this one had x, these will also have x. It does not matter which one you put first. As you start to get the hang of this, you may want to put the 2x first because they both have 2's and the 3x last because those will both have 3's. It won't matter. As long as you do the math correctly, they'll both give you the same answer. Then we're doing grouping like we were doing last class. Split it down the middle. What do those first 2 have in common? X. We take x or divide x out of both of these, what's left? 2x plus 3. Bring down the plus. What do these 2 have in common? 1. And then just the same thing, 2x plus 3 would be left. Then we have to write our final answers. Things on the outside become 1, x plus 1. And the things that are on the inside, if they're the same, you just write 1 plus 1. So that's me double checking that we did it right. They're the same, so we can proceed type thing. Questions on that process? So, not really difficult, there's just more steps involved. A lot of the same stuff we've already done, just all combined into the same problem. Okay, let's do example 2. Same thing. Does this have a GCF? No, other than 1. So nothing will change. So then let's multiply 5 and 6. What would that give us? 30. So two numbers that multiply to be 30, but add or subtract to be negative 17. Say that again. 15 and 2 if they're both negative. Yes, that'll work. So then let's rewrite. 5m squared stays the same. And I'll put negative 15m first because they can both be divided by 5. Negative 2m. And then plus 6. If you did it the opposite way, that's fine. You can still do it that way. It'll still work out. And then split it down the middle. What do the first two have in common? M and not 3, but 5. There we go. We divide both of those by 5m. What's left? M minus 3. Good. Bring down your negative. What do the last two have in common? 2. So remember that you're dividing everything by negative 2, so your signs are going to change. What would be left? If you divided that out, and minus 3. So then what would your final answers be? What would your factors be? Questions on that one? Let's do example 3. Same process. Do we have a GCF? No, other than 1. Multiply 6 and negative 4. And that will give us negative 24. Remember that one of the terms will have to be negative when you look for these. So two numbers that multiply to be negative 24, but add to be negative 5. Add or subtract to be negative 5. And that, would that give you negative 5? Negative. You were close. You just had to switch. Negative 8 and positive 3. So then we have 6y squared. Really doesn't matter. We put either one first. Which one do we want to come first? Okay. Plus 3y minus 8y. If you put the 8 first, that's fine. Keep going. Minus 4. Split it down the middle. What do those first two have in common? 3y. What would be left if we divided them out? What's 6 divided by 3? 2y plus 1. I just didn't do it. And then what would we divide out of these two? 4, but it would be negative, so negative 4. And what would be left? Y plus 1. So then our final answers would be y minus 4 and 2y. We're going to do example 4, move on to some GCF ones, and then move on to some more challenging ones. Does example 4 have a GCF? So multiply 12 and negative 5. What would that give us? Negative 60. So think about the numbers that multiply to be negative 16, then add to the 11. You may want to list out your factors of 60 because there's a lot. So let's rewrite 12c squared plus, let's say I put 15 first, 15c minus 4c minus 5. Split it down the middle. What do the first two have in common? Three and any variables? C. If we divide out 3c, what's left? 4c plus 5. What could we divide out of the last two? 1, but it's negative because of the sign. So negative 1. And then what would that inside be? So then what would your final two answers be? Minus what? 1. There we go. Do we have any questions on this process? How we get these answers? Anything in this? Otis.
I'm solving it. I'm still on the process of it, but I'm doing 12c for power 2 minus 4c. Can we do it that way?
Like switching these two?
Yeah, that's fine. So I'll still get those two.
Mm-hmm. So what's going to happen is when you switch these, the number changes on the outside to the ones that are on the inside.
Okay, that's what I was going to say, because I see that and I was like, I thought it was green, but okay.
So you get the same thing, they're just switched. Okay. On the next page, we're going to skip down to this section. We're going to do the first one 2 different ways, and then we'll do another 2, and then we'll move on. Does this one have a GCF, and if so, what is it? It might be 6. I forgot which one you are. Not 6. 4. Yeah, 4 works. Correct. 452. Evenly. Alright, so it is 4. Yeah, I can run all of them. Okay, so if we divide each one by 4, what's left? we get after we divided these all by 4? So the problem has completely changed, but now the rest of the steps are the same. In all of these, we have to keep bringing down the 4 we factored out, because if we don't, our answer is not right. So multiply 5 and negative 6. And we're looking for two numbers that multiply to be negative 30, but add to be negative 13. If we're multiplying to be a negative 30, one of them have to be negative. Would that work? No. There we go. Okay, so let's rewrite. Keep the 4 out in front. The first and the last stay the same. Rewrite your middle two. Then we can split the middle. What would these two have in common? 5 and what would be left if we divided those out? And minus 3. What could we divide out of these last two? 2, positive 2, so plus 2. And what would be left? Minus, not 2, but 3. There we go. And then when we go to write our final answers, we're going to write the 4. And then still your outside, so 5n plus 2, and your insides. Otis.
So when I did mine, I didn't put 4 next to each of them. I just left it out and then I put
In the front.
4. And when we were factoring, okay, so the 4 on the outside of the parentheses first, right? And then when we went down, we split them. I kind of set it off to the side. And I didn't add it towards the end. Is that okay?
You should probably make it a habit of putting it for each one, because then you might forget if you don't put it at the end.
Okay.
So if you don't put it at the end, that's what will take points off, but you should be putting it all the way through as
It
well.
won't take points off
If you don't, as long as you remember at the end.
Okay.
Other questions on that one? I want you to write this same problem underneath where you have space. If you need more paper, you can grab that.
Is that 20?
20n squared minus 52n minus 24. So if you don't check for a GCF first, this is what's going to happen. You will still get the same thing, but your numbers will be huge. So let's say we forgot to check for GCF when we start the process and multiply those. Multiply those two, tell me what you get. Here's negative 480.
Well, we won't have the right answer because we won't have the GCF question.
We're going to get it.
Okay.
So here you would have to find two numbers that multiply to be negative 480 and add to be negative 52. I don't know the factors of 480, so you would have to go through a long list of numbers. I would say start with something, it's obvious. It ends in a 0, so 5 or 10. 10 might work. 10 and 48. If you made one of those negative, would you get 52? No. So then start going up or down from 10. Does 9 work?
So 480 divided by 9. Yep, 8 and 6 because 9 wouldn't work due to the decimal, but 8 and 60 would. If one of them is negative, which one would be negative? 60. We did find it. So you could start at like 1, 2, and go up from there, but if the numbers are like something that ends in a 5 and a 0, something like that, maybe don't do that, because this might help you. Right? So negative 60 and positive 8. So let's rewrite. 20 and squared. I'm going to put the 60 with the 20. And then split the middle. What do those first two have in common? 20 and Regina.
So like, if the numbers are really big, is there like a really high chance we could by different kind of DCF, or is there
Yes.
sometimes?
That's like almost, I'm going to say like 90% guaranteed. Yes. Because there are some chances that the numbers are just big and there's not. Yeah. That happens. All right, if we divide out 20n, what's left? N minus, not 30, but 3. And what could we divide out of these two? 8, positive 8, which would leave us with. So then we have 20n plus 8 and n minus 3. The n minus 3 cannot be broken down, but this can. What else can we divide out of that? 4, which is where that DCF comes in. What would be left? Now, by all means, this is a correct process. You could definitely do it this way, as long as you remember to factor it still again at the end. But if you did this at the beginning, you wouldn't have to worry about big numbers. So that's something to keep in mind. Questions on that? Right. We're going to go back and do number 11. What is your GCF for 11? This one. Right. We divide everything by 5. What's left?
2.
Plus 15k plus 7.
Okay. Multiply 2 and 7. 14. So two numbers that multiply to be 14 but add to be 15. 14. So the closer those two numbers are, one of your factors is going to be 1. So we'll have 5 times 2k squared. Again, doesn't matter whether you put 1 or 14 first. So this would be 1k or this k. Split it down the middle. What do these first two have in common? 1k. We divide that out with what? K plus 1, 2k plus 1. What would these last two have in common? 7, positive 7. And then our final answer is what we're going to write.
5 and k plus 7.
Do we have any questions on what happens when you have a DCF? Virginia, Lacey, I'm going to be paying attention. I think you don't really have space for this, but either find somewhere to write this down or get out a sheet of paper. And I want you to write these. You're going to end up doing those two for practice, but I want you to write these two problems down. X squared plus 2/3 x plus 1/9, and x squared minus 4/3 x plus 4/9. We're going to do these two together. If you want to write these two down somewhere else, you can try those on your own. And I'm going to show you two different ways you can go about solving these. These will be more questions for our test, not for the SOL, because this is an advanced topic. And we're going to start with the first one. With these type of problems, if we're solving them like we just were, the fractions make it look confusing. So what we could do is get rid of them by multiplying whatever this denominator is. So multiply the entire thing by 9. So that's going to make this 9x squared. What would the middle term be? 6x, and then the last one would just be 1. So now it looks nicer, it looks like something we've done before. So then the process is the same. Multiply 9 and 1. I'm sorry, first, do we have a DCF? No, other than 1. Multiply 9 and 1. We're looking for two numbers that multiply to be 9, that add to be 6. 3 and 3 work. So then rewrite this. 9x squared. Plus 3x plus 3x. Plus 1. Split it down the middle. What did the first two have in common? 3x. What would be left?
3x plus 1.
Plus 1. What did the last two have in common? 1. So 3x plus 1. So then when we go to write our final answers, we have 3x plus 1 and 3x plus 1, or 3x plus 1 squared. All of these types of problems will have a double factor, the same answer twice. That's like the longer way to do it. There's a shorter way, but you would have to know some pieces and how to solve pieces, and I'll show you that too. Before I do that, what questions do we have on this? Otis?
So with the fraction, we're working with the furthest number to the right.
Yes, the C value.
Okay, so like with ones that aren't like 1 and 9, like with 49 and like 36, how would we do that?
It's always the number in the denominator.
So no matter what, I would just do the numerator.
Correct. Multiply everything by 36. You'll get big numbers, but it'll still work out. Okay, and we're going to try that in this one. Sorry, no, we're not. You could try that in this one, but I'm going to show you the shorter way. You're so popular today. Towards the end of the class. Okay, for this one, if you could think about your factors on what they are, really looking at this last one and saying what times what will give you 4, what times what will give you 9, you could write out your factors. So what times what will give you 4? 2. What times what will give you 9? You would have to know what type of signs you need. So this is positive, this is negative, so these would both have to be negative. However, you will not see factors like this with fractions like this because they're all written in this format. So you would have to rewrite these in that format. And to do that, you're going to set it up like this. Sorry, not negative, just positive. So you would just take the number, set it equal to x, and then you're kind of working backwards. Like, if I wanted to get this equal to 0, what would I do? Get rid of the 3/2. 2/3, sorry.
Just replace the 2/3 with x. Are you replacing them in where the parentheses are?
So if I wanted to solve this so that this side became 0.
Oh, x is then 2/3.
So I would need to get rid of the 2/3. So I'm going to move this over by multiplying everything by 3. And then getting rid of the 2 by subtracting. So that that side equals 0. This would be the factor that is equal to this. So that's how you would write it. So you can do it this way, but you have to know how to rewrite the factors.
That's crazy.
Questions on that? I wanted you to try some SOL review before you did any Khan Academy stuff. So I want you to take at least 10 minutes. Let me grab this out also. And I want you to find your testnav. We did this like a while ago. Your testnav, and you're going to use Desmos to work through specific questions. If you've already done these, you can move on to the next ones. So I want you to try numbers 1 through 7 on Desmos. Use your SOL standard to see what we did there, how you can do it here. Resolve them, use your notes, do those 7, and then you can be working on Khan Academy or practice or anything else. If you need an extra test nav, I have extra.